So next one is backgate bias or body effect. See, again, I say all these are small terms which are very important, but they don't have any mathematical significance and they have to be considered while you design your MOSFET. So another important effect is going to be backgate bias, often called as body effect. So you know MOSFET is a four-terminal device, and one must realize that whatever potential you are going to apply, it is with respect to your substrate. So substrate is one terminal which we usually don't connect, but that has plays a major role in the connection or current characteristics of your device. Although the source and the bulk terminals are tied together, bulk means substrate. Okay, there are instances where they are not short circuited. Tied together means short circuited. A quick example that quickly comes into the mind is the current source, where the source and bulk substrate is completely opened out and source is where you give the input. So there are certain instances where the source and bulk are not short circuited. That will give rise to effect called as backgate bias or body effect. So common source connection is at a higher potential than of the bulk and may move around with input common mode voltage. So common source, just like common emitter configuration in common source, they find that at the gate side you have a larger potential than the bulk, because both are not connected. If both are connected means the voltage at the bulk will be equal to the voltage at the source. But since both are not connected together, the voltage present at the source is going to be very high compared to the voltage in the bulk region. As the potential of bulk becomes increasingly negative with respect to the source, depletion region is formed. So again, which will decrease the amount of negative charge in the channel. So finally, everything will impact the drain current, or it will impact the characteristics of your channel. So this decrease in negative charge will increase VGS, so that you have to maintain an inversion layer. So all these, when the VDS is going to be increased, the negative charge will be reduced. So overcoming this one, I have to increase the value of VGS to induce more negative charge, so that the current is flow is maintained constant inside the device. Okay, so all these effects have to be considered while you fabricate the MOSFET. This is a simple example with all the capacitance between gate and substrate. You have the gate and source, this capacitance between gate and drain. This is the current source. This is one more current source. This is between drain and bulk. This is between source and bulk. So these are the different capacitance where which are going to play an effect of a body effect in your device. So because of the body effect, threshold voltage will increase. So this has both large scale and small scale implications. Okay, so you can use the small signal model to analyze the effect of how the body effect is going to cause an impact in the overall performance of your device. And unintended and much undesired, this modulation can also result in currents flowing through the substrate. So this may cause serious problems in mixed signal circuits. So unwantedly, what they say, you might have current flowing in the circuit, which has to be avoided when there is no proper input given to your circuit. It is unintended and much undesired. Nobody wants to have this effect in your device, but when you fabricate, it is obvious that the device will not be completely free from all these effects. So you have to live with that. An extremely careful layout is necessary to reduce noise arising from this mechanism. So only through proper fabrication methodology you can overcome the problems arising because of backgate bias or body effect.